Hello! Today we are going to learn how to perform a gradient descent on a neural network with one input and multiple outputs. This is going to be an easy one, because you have already learned everything that you need to know in the previous video. What we are going to do now is going to be pretty much the reverse of what we have done in the previous video. Instead of having multiple inputs and one output, we are going to have one input and multiple outputs. So everything that was plural will be singular, and everything that was singular will be plural, and everything else will stay pretty much the same. As long as you understand the algorithm for gradient descent, you will have no problem following it. So without any further ado, let's just get started. First of all, I'm going to copy and paste our algorithm that we have done previously to train a single neural network. Once again, calculate error, calculate derivative, update the weights. And sometimes you want to multiply them by learning rate. Pretty much all the time. So now let's just start writing code and see how it works. I'm going to import my NumPy. I'm going to set up our data, except that this time I'm going to name the variable input as INPT, just to avoid any confusion, because if you remember, input is a reserved word, and calling it inputs in this video will be a bit confusing, because we only have one input and it matters here. So let's say it's going to be 10, we will create an array of weights, it's going to be an NP array, because as before, we will need some of the operations that NumPy can perform for us to simplify our code and make it more clear. We will start with a few arbitrary numbers. We are going to create target predictions. This time we have one input and multiple outputs, therefore we have multiple target predictions. To give you an idea of what this could be used for, just remember our tutorial about flowers. So we could have one measurement and it would determine which flower species our flower belongs to. And let's say in this case, we would want to output probabilities for each of the species. So we would want one of the species to be pretty low probability, another one also pretty low, and the final one would be pretty high, so it would consistently predict the good probabilities over here. Finally, I'm going to create a variable for learning rate. Once again, it was set by trial and error, so everything here is just as we used to have. Now we are going to define INN function. It will accept one input and multiple weights. And if you remember, in order to make multiple predictions, all we need to do is to multiply our input by weights. In the original one input and multiple outputs tutorial, we have used a for loop, but here we will just use the NumPy function because it makes everything clearer and simpler. Just remember that this is a single scalar value and this is a vector or array. And we will return predictions. Nice. Finally, we will calculate predictions, calculate errors, and print them out. I will just copy and paste this code because there is nothing different except that instead of one prediction we have multiple predictions. Instead of inputs we have one input, instead of error we have errors that are calculated. Okay, this is actually interesting. Errors are calculated by subtracting target predictions from predictions. And remember that both of those are arrays, so NumPy will perform an element-wise subtraction for us. So array of predictions will be generated by multiplying one input by multiple weights, and target predictions are over here. And finally we will print out what's going on. So there you go, this is our basic neural network. Sorry, I have made a little typo. First weight will be 0.2, just to not have it be 0. So with input 10, we have predictions that look like this, and we want predictions that look like this, exactly as before. Now all we need to do is to write a little for loop that is going to perform our gradient descent operations for us. For I in range 35, once again, this number is picked by trial and error. Once again, we calculate predictions and errors, exactly like here. We print them out to track our progress. The next step is to calculate our pure errors. We are going to do that by subtracting several target predictions from the several predictions that we have made, just as I have explained over here. So nothing different except that we are performing these operations on array instead of singular numbers. Then we calculate our derivatives. Once again, exactly what we used to do, except now instead of multiple inputs, we have one input, and instead of one error, we have multiple errors. So if you look at the original equation over here, in the previous video we had multiple inputs and one output. So this part of the equation remained static for all of the operations. It was just one number, and here we had multiple inputs we had to look through. Now it's the reverse, because now we have several predictions and target predictions, so this outputs an array, and we have only one input, so this contains only one number. Everything else is identical, one input multiplied by array of pure errors, And now we will just update our weights by these derivatives. Weights. We will subtract them as before because we want to move in the opposite direction. We will subtract derivatives multiplied by learning rate. And let's see what happens. Excuse me, I've made a typo. Over here we will use input variable. Excellent. So everything works. We start with our wrong predictions and pretty high errors. Then we keep updating our rates. And after several iterations, our predictions get closer and closer to exactly what we want. And finally they become perfectly matched with our target predictions, and our errors get smaller and smaller and smaller. Basically, we don't need to learn anything exactly new in this video. We have just applied all of the concepts that we have already understood, but to a kind of a reversed situation, a neural network with one input and multiple outputs. I hope everything was clear and useful to you, and in the next video we are going to figure out how to make a neural network with multiple inputs and multiple outputs. And I'll see you next time.